coders, welcome back to our channel GDG Triple MUT. In today's video, we will be discussing the three problems of Codechef contest which was held today, that is Starters 245D. So let's get started. So the second problem name is Cooling Conundrum. Chef is preparing a dessert and as a part of the process it needs to be cooled down. So the current temperature of the dessert is X degrees and it needs to be cooled down to Y degrees. It is guaranteed that X will be always greater than Y. Chef refrigerator can cool the dessert, but the time it takes depends on the current temperature of the dish. Specifically, if the current temperature of the dish is K degrees, then the refrigerator will take K by 10 seconds, rounded up to the nearest integer to reduce the temperature of the dish by 1 degree. It means that if the temperature of the dish is 64 at the current moment, then to reduce it to a temperature of 63, we will require 7 seconds. How, how did this 7 seconds come? We just divided 64 by 10 and took the ceiling value, that is 6.4 ceiling value is 7. So that's how 7 seconds was required to reduce the temperature to 64 from 64 to 63. Similarly, a dish with temperature 21 will require 3 seconds to reduce to 20. How? 21 by 10 is 2.1. When we take the ceiling value of 2.1, we will get 3. Okay? Number of seconds it will take for the dessert to reach Y degrees when its starting temperature is X degrees. An important note is given over here that the temperature cannot directly reduce from X to Y. It gradually reduces by 1 at a time, and for each reduction by 1, we have to calculate the time which will be required to reduce the temperature by 1 degree. So, you may see that sample test cases explained below for more clarity. So, in the input, we will be taking T, that is the number of test cases, and for each test case in we will input two integers X and Y, the initial and the final temperature of the dessert. So let's look at some sample test cases. 38 and 37, the answer is 4. How come? The dessert is at 38 degrees and needs to reach 37 degrees. So this way we will first reduce by 38 by 10. We will first divide by 38 by 10 and then round it off to 4. So 4 seconds are needed to reduce from 38 to 37 because the difference is 1 at the current moment. If the difference will be more, then we will be requiring certain process which we'll be seeing in the code. So let's move on to the vibe coding part. So let's discuss the flowchart of the previous question. So we'll be starting and we will take input T. For each test case, we will take input X and Y, where X will denote the initial temperature and Y will denote the final temperature. Then we will take a variable total time, which will be basically our answer, which will be returning at end. Initialize will be initializing current equal to X, or we can say basically we will be running a loop from current equal to X until current is greater than Y. Okay, so we will be performing this algorithm until that time. So for each iteration we will be calculating our time which will be which will be required to reduce the temperature by 1 degree. So as in the question it was mentioned that we had to take this seal value, that is math dot seal of current divided by 10. So we have taken it and we will add this time into our total time, and then we will be again checking that is current is greater than Y or not. If the answer is no, then we will be printing our total time, otherwise we will be continuing with our algorithm. So this was all about the flowchart. Let's discuss the code. Here we have taken input t. For each test case we will take two inputs x and y and the variable total time, which will be our answer at the end. Now we'll be running a simple loop from current temperature is equal to x until temperature is greater than y, and we will decrement the temperature. Now in at each moment we will be adding total we will be adding the sealed value of temperature divided by 10 to the to our total time, and at the last we'll be printing our total time. So this was it of about second question. Now let's move on to the next question. So now let's discuss the next question, that is equivalent exchange. I will be giving you the overview of this question. In this problem, we have a shop containing only K stones. Some are red and the remaining are blue. We can choose the initial number of red stones, say x. So initially red stones will be x and the blue stones will be k minus x. That will maintain the balance of the entire stones which is there in the shop. Our goal is to check whether there exists some value of x so that during all trades neither red stone or blue stone ever become negative. Means the shop is having enough stones to fulfill the needs of the customers. So let's look at some of the important condition. It is given that if the element at index I, that is the trade factor of the customer, is positive, then he will be giving red stones to the shop, and in return he will be wanting blue stones. And if the trade factor is negative, then he will be wanting red stones and will give blue stones in return. So let's discuss the flow chart of this question. So we will take input t as the number of test cases, and for each test case we will take two inputs n and k. N will denote the total number of customers who visited the shop, and k will denote the initial stones which were there in the shop. We will take three variables, min, max and red balance. Red balance will basically store the balance of the red balls throughout when the customers visited. Minimum will store the minimum of the red balance uh, while iterating through the loop, and maximum will store the maximum of red balance. Be running a loop from I equal to 0 until n minus 1, and for each iteration we will input x, that is the current operation. Red balance, we will add the x in the red balance. It doesn't matter whether x is positive or negative, we will add it in the red balance. X is here basically the trade parameter of each customer. Okay, so minimum will store the minimum of the red balance, and maximum will store the maximum of that red balance whichever came while we iterate through the loop. Okay, so let's check the condition for this. If negative of min is less than equal to k minus max, what is the meaning of this negative min? If the balance say let's say if the balance ever becomes minus 3, then we must have at least three balls in the starting, three red stones in the starting itself, so that we never run out of the red stones in the stock. Okay, now let's see the condition carefully. If we bring this maximum to the left side, we see that minimum plus maximum should be less than equal to k. That means the total stones should remain x. It cannot be should the total stone should remain k. It should not be greater than k. It cannot happen. Okay, if this condition is true, then we will be printing yes, otherwise it is not possible, since this total stones cannot become greater than k. And we will be moving on to the next test case. So now let us discuss the code for this uh, question.
So we will take input t, that is the number of test cases, and for each test case we will take input n and k, where n is the number of customers that who visited the shop that day, and k is the number of stones which were there initially in this shop. Okay, including the red and the blue stones. Min, we will take three variables: min, max, and red balance. Red balance will basically show the requirement of red stones at the current moment. So for int I equal to 0, I less than n, I plus plus, that we will be running a loop from I equal to 0 to I less than n, and for each iteration we will input x, that is the trade factor or the trade parameter for the customer AI. Red balance, at for each iteration we will be adding x. It doesn't matter whether x is positive or negative, we will be adding it in the red balance. And while we will do this, we will update minimum and maximum. Minimum will store the minimum requirement of red balls, and maximum will store the maximum red balls which were there at the moment, at any moment. So if negative of min is less than equal to k minus max, then we will be printing yes, otherwise we will be printing no, and we will be closing the scanner class. So that's it for this question. Now let's move on to the next question. I will be giving you the overview of this question. So we need to build a binary string A of length 3n that contains exactly k ones and 3n minus k zeros. The goal is to make the derived string fa lexicographically minimum. For now, what do you understand by lexicographically minimum? Say we have three strings 0, 1, 1, 1, 0, 0, and 1, 0, 1. So it is already arranged in the lexicographically minimum order, because 0, 1, 1 is it will be less than 1, 0, 0, and this will be less than 1, 0, 1. So lexicographically is basically the order which the dictionary follows. Okay, so we need to make lexicographically minimum means that as many leading zeros as possible. Now if let us consider the case 100, and we have to make it lexicographically minimum. So what do we do is that we pick up all the zeros which is present in that string, and uh, we put it in all of the zeros in starting and shift the ones. In that way it will become the lexicographically minimum. Okay, so each character of fa depends upon the majority of three positions: ai, ai plus 1, and ai plus n, and ai plus 2n. That means we have to divide the string into three parts, such that the we, such that when we pick these elements ai plus n, and ai plus 2n, the most frequent element, let's say this is 0, this is 1, this is 1, so the most frequent element will be 1 over here. So we will append 1 in our fa answer. Okay, so like this we have to take the entire string. Okay, so now let's discuss the approach to solve this question. Now let us discuss the flowchart of the previous question. We will start and we will take input t. The t is the number of test cases, and for each test case we will take input n and k. Okay, here n is the one third of the size of the string a, and k is the number of ones. Okay, calculate 0, that is 3n minus k, and 1 equal to k, means it is given in the question that the k will denote the number of 1 which will be in the string, and 3n minus k will hence denote the number of zeros. We will create three string builders s1, s2, and s3 to represent three parts of a. Since we will be dividing a into three parts, we will take three string builders s1, s2, and s3, and we will add ones and zeros accordingly. Now we will be running a loop from I equal to 0 to I equal to n minus 1, and we will check these conditions. If the number of zeros is greater than equal to 2 and one number of ones is greater than 1, then we will append 0 in S1, 0 in S2, and 1 in S3. Our main aim is to push all the zeros of FA to the front, so that is it is the lexicographically minimum. Okay. Now we'll be checking the next condition. If this is not true, then we will check this. We will check that if 0, the number of 0 is greater than or equal to 3, we will append S1 and S2 and S3 with zeros. Okay. And we will decrement also the number of zeros by 3. And then we will check if the number of zeros is greater than equal to 1, but it will not satisfy this condition, then only it has come here. So if we will be checking that if number of zeros is greater than 1, if that is the case, greater than equal to 1, if that is the case, then append 0 to S1, 1 to S2, and 1 to S3. And else, if it is not the case, so we will append 111 to all the string builders, and then we will be concatenating the strings s1, s2, and s3 in our answer, and we will be printing our answer. That was the flowchart of this question. Now let us discuss the code. So as per the flowchart, I have taken T, that is the number of test cases, N and K, where K will be the number of ones and N3 and minus K will be the number of zeros. We will be taking S1, S2, and S3 as three string builders, and we will be calculating how many zeros are there and how many ones are there. Now we will be iterating from I equal to 0 to n minus 1, and we will be putting these cases as was discussed in the flowchart. If the number of zeros is greater than 2 and simultaneously one number of 1 is greater than equal to 1, then we will append S1 with 0, S2 with 0, and S3 with 1, and we will decrement the number of zeros and ones. Else, if the number of zeros is greater than equal to 3, if this condition is not satisfied, then only we will be moving on to this. Okay, so as we will append the all three string builders with 0. Else, if the number of 0 is greater than equal to 1, that means this condition is also not satisfied, then only we will be moving on to this. Okay, so s1 we will be appending s1 with 0 and s2 with 1 and 1 respectively, and we will decrement accordingly. And then we will if otherwise we are not left with any 0, then we will append 111 to all the three strings, and we will decrement 1 by 3. Okay, now we will be concatenating these strings into our answer. We have converted these string builders into string first, and then we have concatenated, and then we have stored it in our answer, and then we have printed our answer. So this was it for today's Codechef session. Thank you, and now we will be meeting in the next video. Thank you.